Welcome to Zeta. Our company is located in Shanghai, China. Our main business is injection mold making and injection molding products, mass production. This video will share.
How long does an injection mold last? The lifespan of an injection mold can vary depending on a number of factors. The material that is being molded, the type of mold material, design of the mold, the amount of use it undergoes, the quality of maintenance and upkeep, number of mold cavities and average. An injection mold can last for around 100,000 to 500,000 cycles. But some high-quality molds can last for up to 1 million cycles or more. However, it is not uncommon for molds to start showing signs of wear and tear after a few hundred or thousand cycles, requiring repair or replacement. The material that is being molded can have a significant impact on the lifespan of an injection mold. A. Different materials have unique properties and characteristics that can affect the durability and longevity of the mold. For example, some materials may be more abrasive or corrosive than others, which can cause wear and tear on the mold more quickly. B. Harder materials, such as PA with glass fiber, can cause more wear and tear on the mold compared to softer materials, such as PP. Additionally, materials with high melting points can also cause more stress on the mold, resulting in a shorter lifespan. C. Additionally, certain materials may be more challenging to mold than others, which can also affect the lifespan of the mold. Materials that are more difficult to mold may require more complex or intricate molds, which can be more susceptible to damage and may not last as long. D. Furthermore, the conditions in which the material is molded can also impact the lifespan of the injection mold. For example, materials that are molded at high temperatures or under high levels of stress and strain can cause more wear and tear on the mold, which can reduce its lifespan. The type of mold. Different types of molds are designed for different purposes and can be made from a variety of materials, each of which has its own unique properties and characteristics that can affect the durability and longevity of the mold. For example, some types of molds, such as single cavity molds, are designed to produce only a single part at a time. These molds are generally simpler in design and require less material, which can make them less expensive and more durable than other types of molds. On the other hand, multi-cavity molds are designed to produce multiple parts at once and are generally more complex in design. These molds may be more expensive and may not last as long as single-cavity molds. The type of mold. Material from which an injection mold is made can have a significant impact on its lifespan. Injection molds can be made from a variety of materials, including metals such as steel and aluminum, as well as plastics and other composite materials. Each of these materials has its own unique properties and characteristics, which can affect the durability and longevity of the mold. A. Steel is a common material used for injection molds, and it is known for its strength and durability. Steel molds can last for many years if they are properly maintained and used correctly. They are also resistant to wear and tear, which can extend their lifespan even further. B. Aluminum is another popular material for injection molds, and it offers many of the same benefits as steel, including strength and durability. However, aluminum molds are typically not as strong as steel molds, so they may not last as long. C. Plastic and composite materials are also sometimes used for injection molds, especially for applications that require lightweight or corrosion-resistant molds. These materials can be less durable than metal molds, and may not last as long. However, they may be more suitable for certain applications. such as those that require molds with intricate details or complex shapes. Overall, the type of material used for an injection mold can have a significant impact on its lifespan. Careful consideration should be given to the material chosen, as well as its properties and characteristics, to ensure that the mold is able to meet the needs of the application and provide long-lasting performance. The design of the mold. The design of a mold can greatly affect its life and overall performance in the injection molding process. A well-designed mold will be able to withstand the high pressures and temperatures of the injection molding process, as well as the repetitive stress of the constant injection and ejection of plastic parts. Another important factor in mold design is the inclusion of cooling channels. These channels allow for the circulation of coolant, which is essential for maintaining the proper temperature of the mold and preventing it from overheating. Overheated molds can become distorted, leading to poor part quality and a shortened mold life. Properly designing the ejection system of a mold is also crucial for its longevity. The ejection system is responsible for releasing the molded part from the mold once it has solidified. If the ejection system is not designed properly, it can cause wear and tear on the mold, leading to a shorter life. In summary, the design of a mold plays a critical role in its life and performance in the injection molding process. Factors such as material choice, cooling channels, and the ejection system all need to be carefully considered in order to create a mold that will be able to withstand the demands of the injection molding process and produce high-quality parts. The amount of use that undergoes molds that are used frequently will inevitably experience more wear and tear than molds that are used infrequently. This can lead to a shortened mold life and a decrease in the quality of the parts produced. One way in which the amount of use can affect mold life is through the accumulation of debris and contamination. As a mold is used repeatedly, it can become contaminated with bits of plastic and other materials. This contamination can interfere with the molding process and cause defects in the molded parts. It can also cause wear on the mold itself, leading to a shorter life. Another way in which frequent use can affect mold life is through the buildup of heat and pressure. Injection molding involves the application of high heat and pressure to melt and shape plastic into the desired shape. Over time, this repeated exposure to heat and pressure can cause damage to the mold, leading to a shortened life. Furthermore, frequent use can also lead to the formation of cracks and other defects in the mold. These defects can compromise the integrity of the mold and make it more susceptible to failure. In conclusion, the amount of use a mold undergoes can greatly impact its life and performance in the injection molding process. Molds that are used frequently are more likely to experience wear and tear, contamination, and defects, which can lead to a shortened mold life and the quality of maintenance and upkeep. Proper maintenance and upkeep are essential for ensuring that a mold remains in good working condition and continues to produce high-quality parts. One way in which the quality of maintenance can affect a mold is through the prevention of contamination. Molds can become contaminated with debris and other materials over time, which can interfere with the molding process and cause defects in the molded parts. Regular cleaning and maintenance of the mold can help prevent this contamination and extend the mold's life. Another way in which good maintenance can affect a mold is through the prevention of wear and tear. Injection molding involves the application of high heat and pressure to melt and shape plastic into the desired shape. Over time, this repeated exposure to heat and pressure can cause damage to the mold, leading to a shortened life. Regular maintenance and upkeep, such as lubrication and tightening of bolts, can help prevent this wear and tear and extend the mold's life. Furthermore, Regular maintenance and upkeep can also help identify and address any potential defects or problems with the mold before they become more serious. This can prevent costly downtime and extend the mold's life. In conclusion, the quality of maintenance and upkeep are essential for ensuring the longevity and performance of an injection mold. Regular cleaning, lubrication, and inspection can help prevent contamination, wear and tear, and defects, extending the mold's life and improving the quality of the parts it produces. The number of mold cavities can have a significant impact on the life and performance of an injection mold. Molds with multiple cavities are able to produce more parts per cycle than molds with fewer cavities. But this can also lead to additional wear and tear on the mold. One way in which the number of mold cavities can affect a mold is through the increased production speed. Molds with multiple cavities are able to produce multiple parts in each injection molding cycle, which can greatly increase the overall production speed and efficiency. However, this increased production speed can also lead to more wear and tear on the mold, potentially shortening its life. Another way in which the number of mold cavities can affect a mold is through the increased complexity of the molding process. Molds with multiple cavities are often more complex in their design and require more precise control of the injection molding process. This added complexity can lead to a higher likelihood of defects and other problems, which can reduce the mold's life and performance. Furthermore, the number of mold cavities can also affect the quality of the molded parts. Molds with multiple cavities often require more careful alignment and control of the injection process in order to produce parts with consistent quality. If this alignment and control are not properly managed, it can result in poor part quality and a shorter mold life. Summary: the life of an injection mold can vary greatly depending on a number of factors, such as the design of the mold, the materials used, the amount of use it undergoes, the quality of maintenance and upkeep, and the number of mold cavities. In general, however, an injection mold can last for many thousands of cycles before it needs to be replaced. In some cases, a well-designed and maintained mold can last for millions of cycles.